Hello everyone, and welcome to another video in my channel. In this video, we'll have a factorial equation to solve. The quantity x plus 2 factorial minus 12 times the quantity x minus 1 factorial is equal to 16 times x factorial. We are given that x is a member of the set of positive integers, meaning that x must be a positive whole number, and so we are asked to find the value of x. What do we know about the factorial? If I have n factorial, it can be expanded into n times n minus 1 times n minus 2 up till I have 1. Therefore, I'll keep on removing 1 from this term and this term until I get to a part where I'll have x minus 1 remaining, so that I can factorize x minus 1 out, and then I can convert it to a polynomial equation. So having said this, let's now start removing 1 from these terms. So I have x plus 2, x plus 1, if I remove 1 from here, then times x and x minus 1 factorial. I'll stop here because I have x minus 1 here. I want to factorize them out. Then I'll do the same thing here. This is minus 12 x minus 1 factorial. So I was saying I'll do the same thing here. 16 times x minus 1 factorial. I will have to factorize x minus 1 factorial out. So x minus 1 factorial times x plus 2 times x plus 1 times x. Let's remember that this should be a big bracket. Minus 12 times the big bracket is equal to 16x times x minus 1 factorial. This will cancel this. We now have a polynomial equation remaining. So x plus 2, x plus 1 times x minus 12 is equal to 16x. If we open these brackets, we have x squared plus 3x plus 2 times x minus 12 is equal to 16x. Still opening, x cubed plus 3x squared plus 2x minus 12 is equal to 16x. Let's now move this 16x to this side of the equation. So we have x cubed plus 3x squared minus 14x minus 12 is equal to 0. Because minus 16x plus 2 will give us minus 14x. Now we have a polynomial equation. That means that we are going to have 3 solutions. If we check, one of the solutions is x is equal to 3. If I put 3 where I see x in the polynomial, I have a balanced equation. 3 cubed plus 3 times 3 squared minus 14 times 3 minus 12 is equal to 0. 3 cubed is 27. And 3 squared is 9 times 3 is 27. Minus 14 times 3 is 42. 3 minus 12 will give us 0. 27 plus 27 is 54. Minus 54 here again. So x is equal to 3. If x is equal to 3 is a solution or is a 0 of this polynomial, then it means that x minus 3 is a factor of the polynomial. To find the other factor of the polynomial, we have to divide this polynomial by its factor. So we have a long division. Here we have x to power 3 plus 3x squared minus 14x minus 12. And here we have x minus 3, which is the divisor. Now, x to power 3 divided by x will give us x squared. X squared times x will give us x to power 3. And x squared times minus 3 will give us minus 3x squared. If we subtract, we'll have 6x remaining because minus times minus is plus. And 3 plus 3 is 6 squared. Now, this minus this is 0. Let's bring down this term minus 14x and continue with the division. 6x squared divided by x will give us 6x. 6x times x will give us 6x squared. And 6x times minus 3 will give us minus 18x. If we subtract, this and this will cancel out, and this minus this, 4 times minus 3 will give us minus 12. If we subtract it, we'll have 0. So x minus 3 is a factor of this polynomial because we have remainder 0. So we have a solution. Our first solution is that x is equal to 3. Let's now find the other solution by equating this factor of the polynomial x squared plus 6x plus 4 to 0. To find the roots of this quadratic equation or the zeros of this quadratic equation, we have to check if we can factorize it. To check it, let us use the discriminant in the formula. The formula is x equals to minus b plus or minus b squared minus 4ac all over 2a. The discriminant is b squared minus 4ac. So b squared minus 4ac will give us b is 6, that is 36, minus 4 times a is 1 and c is 4. So 36 minus 16 will give us 20. We cannot factorize it because we don't have a perfect square, which is the discriminant. So we have minus b, that is minus 6, plus or minus the square root of 20 all over 2 times 1 is 2. So x equals to minus 6 plus 20 can be written as 2 root 5 all over 2. So I have minus 6 plus 2 root 5 all over 2, or minus 6 minus 2 root 5 all over 2. However, let us remember that the condition we are given is that x is a member of the set of positive integers. These are not integers, rather these are irrational numbers, and so we will reject these two solutions. So x is equal to 3 as we solved in the first case. Let's now back substitute the value of 3 for x in the original question. The question is x plus 2 factorial minus 12 times x minus 1 factorial is equal to 16x factorial. So let us put in the value of 3 where we see x. This is 3 plus 2 factorial minus 12 times 3 minus 1 factorial is equal to 16 times 3 factorial. 3 plus 2 is 5. So I have 5 factorial here minus 3 minus 1 is 2. That is 12 times 2 factorial is equal to 16 times 3 factorial. 5 factorial is 5 times 4 times 3 times 2 times 1 minus 12 times 2 factorial is still 2 because 2 times 1 is 2 is equal to 16 times 3 times 2 times 1 factorial. Now 5 times 4 is 20 and 20 times 3 is 60. 60 times 2 is 120. So we'll have 120 here minus 12 times 2 is 24 is equal to 16 times 6 will give us 96. 120 minus 24 is 96. So 96 is equal to 96 and x is equal to 3 as the solution.